So this theorem is about if a pair of opposite sides of a quadrilateral are equal and parallel, then it is a parallelogram. So if only one pair of opposite sides are equal and parallel, we need to prove it is a parallelogram. So let's see this one. Here given information. So first we will write the given data, then we'll explain with the diagram. So given information is ABCD is a quadrilateral and only one pair. So let us take one quadrilateral, four sides, one pair. So this is equals to this side. So these two sides are equal and the two sides are parallel. We need to prove this is a parallelogram. Yeah, see here. So ABCD. So ABCD is a quadrilateral and given is AB is equals to DC. AB is equals to DC and AB is parallel to DC. These two. So pair of opposite sides. A pair, only one. Pair of opposite sides of quadrilateral equal and parallel. So these two are parallel. At the same time, these two are equal also. Okay. So AB is equal to CD and AB is parallel to CD. Then we need to prove. So to prove, so we have to prove here ABCD is a parallelogram. ABCD is parallelogram. We need to prove now. So let's see some. So we need to make one construction because we need two triangles to prove congruent. So we need the concept of congruency only. We will prove this construction. So I am doing one construction here. Just join A and C. So in diagonal construction here. So join A to C. Then ABC is a triangle and ADC is another triangle. So construction is join A and C. So vertex A and C are joined. So AC is a diagonal. Okay, when we see the proof from ABC and CDA. Okay, ABC and ADC. From triangle ABC and triangle ADC. So from these two triangles we have to prove first congruent. So to prove congruent we can take one of the any one axiom. So here AB is equals to DC. First we will write the given data. From the given AB is equals to DC, right? So AB is equals to DC. This is the given data. And AC is equals to CA. So it's a common side. AC is equals to CA. And this is the common. So common side for both. And angle BAC. So whenever two line segments are parallel and one is transversal, here this angle, and you can observe here these two angles are equal. So BAC and ACD. These two are equal angles because alternate angles. So AB is parallel to DC and CA is a transversal. Okay, AB is parallel to DC and CA is a transversal. Therefore, we can write angle BAC is equals to DCA. So this is for alternate angles. So alternate angles. As AB is parallel to DC and CA is a transversal, right? Therefore, then we can say according to this SAS axiom, two sides, one angle. So common side and given sides are equal and common angle. Therefore, triangle ABC is congruent to triangle CDA, right? So this is a SAS axiom. So according to the SAS axiom, these two triangles are congruent. Then by CPCT, whenever two triangles are congruent, and angle BCA we can conclude that these we can take another pair. So here, yes, this angle and these two angles, then mark the blue, BCA and CAD are equal. I'm taking because ABC is a congruent to CDA, so I can write angle BCA is equals to angle DAC, right? This is a CPCT. Okay, corresponding parts of congruent triangle. But these are alternate interior angles, right? So these two are alternate interior angles. If these two angles are equal, then indirectly AD is parallel to BC. Okay, these two angles are equal and AC is transversal. So obviously AD is parallel to BC. Therefore, AD is parallel to BC because these are alternate interior angles. Then we can say, so already given data, now given values are AB is parallel to DC. This one pair is given and we got just now AD is parallel to BC. So opposite sides are parallel, hence we can conclude that ABCD is a parallelogram. ABCD is a parallelogram. We can confirm that because AB is parallel to DC is given and AD is parallel to BC. So opposite sides are parallel. Therefore, then this also AD is parallel to BC. Then when opposite sides are parallel, then it's a parallelogram, right? So we can say that. And the diagonals of rectangle are equal, then they bisect each other. So one more theorem I will prove. This is for parallelogram. So next I'll explain you some other theorem about diagonals in rectangle. So let's see that also now.